Hello out there in remote learning land. Today's hot topic, humidity. Yeah, those muggy summer days where you just can't cool off because your sweat won't evaporate. Well, blame that on humidity. And as gross as you might think that picture is, we've all been there. Yep. Humidity is moisture in the air, folks. So our little cartoon, I hope you get a chuckle out of that one. Is it humid today or what? And there you have the fish swimming right behind as they're walking. Yep, it's the reason we have bad hair days, the reason we get super uncomfortable on those muggy summer days. All that moisture in the air doesn't allow our sweat to evaporate and bring our body temperature down. All right. We'll start out with a little commercial here for all those bad hair days. Check it out.
As time ticks on, is your sleek long gone? Get ready. There's an all-new Sleek and Shine from Garnier Fructis. Powered by argan oil, now it can lock out frizz for a full 48 hours.
Proven.
Hair stays super smooth.
Proven.
Even in 97% humidity. Keep it sleek 48 hours straight. All new Sleek and Shine with argan oil.
Discover the new Garnier Fructis. Advanced fruit science. Incredible new formulas.
Garnier, take care.
Now, I'm not a big Garnier hair poo kind of shampoo kind of guy, but anybody I've ever spoken with that used the product said, well, it works, but not for 48 hours, right? It might work for, might get you to the afternoon, but it certainly won't work for 2 days. Moisture is going to find its way into the hair, and when it does, you get that frizzing effect because it literally causes the hair to change its length and then, of course, curl up. Okay? So anyways, humidity, get your official definition down there, right? The measured amount of water vapor in the atmosphere. All right. Humid, hot and moist conditions will give you less evaporation. We spoke about evaporation yesterday. But if it's arid, that's another word for dry, right? Like the deodorant, arid, extra dry. Well, certainly you would get more evaporation there, and that would be like Arizona. All right. How does humidity affect evaporation rate from yesterday? Hopefully you remember the more moisture is in the air, the less the evaporation rate is going to be. Okay? Okay. And how about this situation here? So why is one person happier than the other if it's the same temperature outside? Well, both have the same 95-degree day. Both are very hot, but I don't know if you've ever been down in Florida or if you've been at Disney World. Waiting on those long lines and that humidity is just unbearable. They have the fans on and all that, but bottom line is if there's that much moisture in the air, then your sweat cannot evaporate. Okay? Whereas this person over here, they're hot, but their sweat is evaporating, bringing down their body temperature. And their sweat, of course, is going into the air, and that, of course, is much more comfortable. Okay? How much moisture can the air hold? Please take a minute and read this through. Okay, it talks about capacity. Hit pause and read that through. All right. Warm air holds a lot of moisture, right? So we know that warm air expands when it's heated. Also has the ability to hold a lot more moisture. Cold air holds much less, of course, right? It's contracted. You want to think of it as there's not enough room in there for moisture. It's one way to think of it. It's a little different, but it certainly helps you remember it. Certainly, if on a day like today, 70 degrees or so outside, all that water's evaporating into the air, and of course, when nighttime comes, well, that moisture's got to go someplace, and that becomes dew. All right. There you have your water droplets in the air compared to the cold, right? So the warm clearly has a lot more moisture in it, these cute little moisture droplets here, and the cold air can't hold as many. That's also why your skin gets drier when it's colder outside, because there isn't as much moisture in the air, right? All right, please hit pause, read this one through well. It talks about relative humidity. We talk about what percent humidity it is today. Well, that's relative humidity. Okay. And the best way to visualize it is like with cups or containers. Let's say you have a small container and you fill it totally up with water. All right, it's 100% full. Now, take that water, pour it into a bigger container. Don't add any water, but pour it into a bigger container. Now, let's say it's only about half full, so that's 50% relative humidity. Now, take that same water, pour it into an even bigger container, and now look how much more airspace there is, right? You can hold a lot more water, so the humidity, the relative humidity, goes down. Now it's only about 25%. Mind you, the absolute humidity, the absolute amount of water stayed the same each time. But because the container size changed, the relative humidity ratio changed. This is what happens when you change the temperature of the air. And that's why there are temperatures here, 0, 10, 20. When you increase the temperature of the air, you can hold more water vapor. Okay? So write your definition down there for relative humidity. Right, it compares how much moisture the air is actually holding versus what's in there. All right, if the air is saturated, you're at 100% humidity. That's only going to happen when it's raining or if it's just one of those super duper muggy days. But even if the humidity was 80%, let's say, let's say it's a hot summer day, even if it was 80% humidity, that feels unbearable. So to get to 100%, I mean, the air is just like thick fog, complete. You could cut that moisture with a knife. All right, here's another diagram to visualize it, but similar to what you just saw before. Okay. Increase the temperature, your relative humidity will decrease. That's what's going on here. Increase the temperature, the relative humidity decreases. Decrease the temperature, like when you go into nighttime, then the relative humidity increases. As soon as you hit 100% relative humidity, when the temperature drops, dew starts to form. All right, and that's our next slide here. It's called hitting the dew point. So hit pause, read this through. Okay, when you drop that temperature, let me double back one. When you drop that temperature until you hit this 100% relative humidity point, boom, that's the dew point. Okay, that's what this was all about. And of course, you can see the beautiful dew on the leaves. If you actually look closely, you'll see these gorgeous droplets. Of course, if you cut across your neighbor's lawn wearing your new sneakers in the morning, you know you've just got your sneakers all wet. You got wet feet for the day. And even if it didn't rain, they'll still get wet because of the dew. Okay? The dew point temperature is when condensation occurs, right? The air becomes saturated because the temperature dropped. So make sure you get that in your notes. All right. And of course, you'll have some summary questions to go through. All right. So please pause, making sure you get good notes down. Take your time on the questions, and we'll meet back up in the meet.